Hi, Nicholas.
Hi.
Hey, hi. I hope I'm audible.
Yes, I can hear. Can we already start, or do you have to wait for something?
You can go ahead for the interview.
Yeah. Okay. So I think it's a second interview. So I will introduce myself, and before that, how to pronounce your name correctly? Is it Jay?
Yeah.
Simply Jay. Ah, perfect. So I'm Nick. So just name me Nick. Forget the rest of my name. I think it's a second interview. You're an Android developer, Jay, as far as I understood, and you are applying for a position for the automotive domain, basically.
Yeah.
Yes. So I already looked at your CV. I'm really curious about you. But before that, maybe first let me introduce myself a little bit. So my name is Nikolaus B. Basically, I have a PhD in human-machine interaction with focus on AI topics. I joined BMW 2011 already and started in the driving simulation environment where I was responsible for the software there. Upon a time switched then to the serious development where I am currently the lead architect for the context platform, which is, when I look at your CV, I think you're not so far away from what we're doing, but maybe a little bit different. Therefore, I hope we have some things to talk about. So I hope you understand me well, by the way. So,
Yep.
so if, good. And what is the context platform? Maybe I dig into that a little bit after you introduce yourself. Then I will a little bit explain what the context platform is about. And then we could just check what the things you did would fit to the context platform. Is it okay for you?
Yeah, that's fine. So myself,
Good.
Jay, I have been into native Android application development from past 8.5 years. My current stack is like pure Kotlin with MVVM, Compose, core routines, and all of that stuff. But prior to Kotlin, I have worked on Java with 4 years of experience as well. So yeah, now that we use the full stack is like in Kotlin, and currently into the BPME app. Like it's a pump fueling app basically for different regions. For example, US, Netherlands, and UK. So yeah, that's a bit about me. Do you want like previous project which I worked on, like from Paytm?
I read it already. It's impressive anyhow. So maybe we use the time a little bit to dig into some details. So first, I may explain you a bit what the context platform is about. And I see that you have this apps developed, and I could imagine that data was also a topic, how to get information from somewhere. So because I can see from some things you had this live data, but let's dig into it because I'm not fully an expert in Android, I have to say, but let's dig a bit into some techniques and try. You will explain me some things, and then we will have a discussion. So, what is the context platform about? We are on the automotive side, and we are trying to develop here now AI in the car, basically. So it's on edge. So it's not so much that we want to enable it for the backend. I think we already have that to some certain extent. And now we are thinking about how much can we get into the car from all AI functionality that you may have. So this is maybe you're familiar, or at least you heard it. I think not in your CV, but you heard of things like this ChatGPT and large language model stuff and all these kind of things. And whenever you interact with those systems, so there is a risk that it uses data that is not correct. So the question is always how to extract the correct data for these huge models that have a high probability and likelihoods, and it's named hallucination, for example. Maybe you heard this term, maybe not, but it's you ask, for example, for, I don't know, temperature in your car, and then the system doesn't deliver you the temperature in your car, but maybe from the engine. So could happen. Yeah, there's just like there is a random thingy that selects some data. I think nothing with the technologies you had. Whenever you show some data value to the user, then it's always the data you wanted to show. Or have you experience with this kind of probabilities in AI systems?
So there was one small use case in our app, not the whole LLM. So basically, there was one chat and FAQ powered screen with the chatbot. So it was a in-house chatbot. So it was an integration of MLKit library. So yeah, that was it. I mean, mostly. But other than that, usually we have our own gRPC backend server. The app's data is driven by gRPC. Yeah.
Okay. So you are also
And on the
experienced with
and on
gRPC.
the app side, we use Stateflow and live data for that.
Mm-hmm. So you always get the data basically you want, because when you use gRPC, then you really know what you want. When you have, for example, imagine that you have via gRPC some streaming of data, many data points. I don't know what it could be. You can imagine when you're in a car environment that there are a lot of sensor data and stuff.
Yeah.
You just bring this via gRPC to interface via LLM, and then tell the LLM, please select the correct one. So you can easily imagine that it selects the wrong one.
Yeah.
Of
Because
course, we can fine tune.
if the intent is not clear, it will fall back to some other thing.
Exactly.
Yeah.
Exactly. And I already have it at home, for example. So I ask just my system, I don't know, is the light on in the kitchen? And then it says yes, and I go to the kitchen, it's not on.
Yeah. I mean,
So this is a thing we want to avoid, and that's why the context platform is there. So that's a third pillar. We have basically three pillars. We have the generative AI, which is this large language model, this GPT stuff. Then we have the machine learning, which is another pillar, which maybe goes more into expert systems where we really train models for specific tasks.
Mhm.
And then we have the context pillar, which needs to provide all the data for the user with whatever they're interacting with. So for example, I bring one example, then you can maybe imagine. You want to open so you're in the car, you're driving, and you want to open your son's window to get fresh air in.
Okay.
And then you just tell the system, please open my son's window.
Mhm.
Now you can imagine that the context platform needs to figure out many things. First, what is my son?
Mhm. Mhm. Yes,
Second, does your son have a window close to him? So is there at the seat your son is sitting, maybe is there a window? And then you need to call the right window handler. And this is just in short somehow what the context platform is doing, and where we handle all the data. So maybe we can play a bit, and why we're doing it is maybe now important for this little discussion I would like to have with you. Can you imagine, so when you don't have an internet, so of course you could say always do this at the back end, so you don't have the resources in the car, so just send the data back, and then you have some Amazon cloud or anything like this
AWS.
there, and then you do that. Or you can do if then else algorithmic all the time. You can always say, if you say son, then look up whether you have a son, and then kind of quite old style algorithmic approaches, which of course don't scale. That's the problem. So it doesn't scale to have all these if then else thingies, and it doesn't also scale if you put everything in the backend if the internet connection is gone.
Mm-hmm.
And the first question I would have to you, what idea would you have to circumvent connection issues when you have, for example, data in the backend, but also on board? So, for example, the knowledge about your son is in the backend. So the backend knows you have a son. Maybe it has some facial information about the people that are commonly in the car, tagged to some names. And now my son goes to the backend because you don't have the onboard capability. And how would you circumvent now connection issues? Because if you have a connection issue, no internet connection, well, then you won't get an answer. So do you have techniques that the user would not have to repeat things all the time, or what would come to your mind to circumvent that? Is already solved with typical protocols or whatever?
So one thing I feel is like, let's say after while speaking, if the internet goes on, obviously the request cannot go through, but you still have that speech. Like, let's say if I have like spoken, open my son's window, right? So there are two contextual word which I can think. One is son and second is window. Obviously window would be of car, because obviously we in a car infotainment system, and that's by default.
So we find the handler in the car.
Yeah. Obviously we have that handler attached or service attached.
Yes.
Second thing, like the one thing you told, you went offline, so there is caching mechanism. We can store the data locally as a transcript file, so whenever the connectivity is back again, so obviously we get some notification and we can process that commands now to the server. Right.
Yeah.
The only case which which will not be handled is, I believe, the backend itself is dead, or maybe a 500 or 503. So in that
Okay,
case, that's a
assume
different case.
this is running. We just have this typical issues with internet connection,
Yeah.
which can have in a garage or somewhere where it's not well covered. And this is then you say you buff it. Do you know techniques how this can be done? So from the software point of view, are there some frameworks in Android already dealing with it? Are you familiar with it? Did you have to deal with it? So I have many questions.
Yeah, so I haven't deal with such scenario, but
Huh?
we have deal with the DB layer, right? Database layer, local level
Huh?
caching, and then there is one, I guess, layer. I don't remember the exact word in automotive OS. So we can store as a transcript file as well, because let's say if the user has spoken too much of things, so we will not be storing huge data. So anyways, backend will be expecting transcript format for that to process, because at backend if we keep sending um, .mp3 files or recording of the user, right? So it will be difficult to catch every text, because every text needs to be pre-processed, like in terms of token. So if it needs to go in terms of token, obviously text would be better, I believe.
Yeah, but it's okay. So there are already some things in. So especially that you just say, then why not store it in the car in between? And what you can then also do, I think this is trivial, store it for some certain time, and then you can sync it whenever the connection is back. And you also could then extend it, I guess, to something like there's typical stuff stored. For example, I don't know, up to 10 face ideas that commonly are in the car, so that we always can use them when they match with the interior camera algorithm thingy. I don't know. Maybe it doesn't work. It's too far away. Sorry. Okay, let's think a little bit in the things, and maybe come back later to this example again to the things you did. I saw some so I looked basically at your keywords, and I saw this. Of course, JRPC. We will dig into this little bit later. But also, you had this REST API. You had this live data. You had this retrofit thing. Can you explain me a little bit? I don't know. What can we combine? I think it somehow belongs together, but
anyways, I will explain live data and retrofit and REST API as well. So that's not an issue. So live data is basically life cycle aware holder class on Android stuff, which holds the data. Now we usually don't use, because it is for only one single time operation. So obviously if we want streaming of the data, so we use state flow for that. You might have seen flow as a keyword in my resume as well. Yeah, so we use flows for that. And retrofit is the network layer call of the Android to do the network processing to get the data. For example, if you are on any food delivery app, and if you are trying to order some data is in your cart, so the server, obviously it needs to be sent to the server, right? Server should know like customer is ordering something, and then based on that it will send a request to the another like the restaurant partner. So there the order will be accepted, and then again the notifications will come into the app. So for that we need retrofit, basically network call. How would you go
Can I jump into? But isn't that the mechanism we would look for to prevent this internet connection issue? Let's say, so does this retrofit take care of getting the data in a sense of, hey, please give me the name of this face? Then you organize the sending.
Give, but only when internet is available. Yeah, this is the
And if it's not available, it does not have a mechanism to buffer things and so you know what I mean. So you really have to do this by yourself, because I'm not so familiar with retrofit. But I thought maybe at least it makes the internet connection. It gets the data from the backend. It checks that the data is there.
Can be detected via connectivity observer itself. So we don't need retrofit. We need retrofit to perform network request. But if there is no internet, or if we want to know whether internet is connected or not, there is a connectivity observer for that. Yeah, that's default
but it's
from
still
Android.
It's still quite toughly tight, so there is no buffer mechanism. So this is still things we need to develop by ourselves, basically. Okay, I got it. Then for the live data, how does this play into it?
Live data is like it's a data holder class, like which holds our data. So we use
Yes.
now we use flow, but earlier we have used like live data as well. If there is a single one-time operation of event, like let's
Uh-huh.
say you ask something from API and API return the response. That's it. You are done. You will get the data, and you don't need to keep on getting subscribe for every event, future event. So it's like one-time thing. Yeah. So usually we don't
Ah.
use. Yeah, we use state flow.
Okay. So I'm not now familiar with SafeFlow, but nevertheless, but also this is not a mechanism we could use to. So is it just for UI or is it in general for apps basically? So you
It's
have
in
the
general
live.
for all the Android apps, not just
Okay,
for UI.
so yeah, because why I ask these kind of things, I have, so we're still in the context world, so we still
Yeah,
try
yeah.
to get data, and we're in the context platform that tries to transfer data from A to B, to sync it from there to there, and also in the car basically. And the question is whether one of these mechanisms that are, I think these are Android mechanisms, are they?
Yeah, I mean Android. It's Android.
Yeah. And I just thought about maybe there are already techniques that simplify our life, because what we're currently doing is we're trying to rebuild things itself. And maybe therefore you can explain me the gRPC, how you used it, and in comparison then maybe later on to live data and retrofit. That would be interesting for me.
Okay. So basically, gRPC is our actually backend server which we integrated in your app. So basically, earlier we have REST as well, REST API, but here our backend was gRPC because the protobuf format is very much light because it contains binary data. It's not a whole raw string like JSON, which is the case in REST API. So it's by default very much in KBs. So our app size is very much very much less, and the response time is like within milliseconds we get the data if we compare to JSON. Yeah. So that's the main thing. And one more like best thing about gRPC is like it supports bi-directional streaming as well. Yeah.
Yes.
Yeah.
That's good. And what happens when the gRPC connection is broken, basically? So, sorry, when the internet is gone, what does gRPC do? Does it have any mechanism to circumvent it, or is it like you have to do this by yourself again? So imagine you want to stream data, and now suddenly the internet connection is gone. And after 5 minutes, it comes back again. So what would be now? So you want to stream, I don't know, continuous temperature data back to the backend from your car, and now the internet connection is gone. What's happening? And how could you solve it?
I mean, the connectivity observer will automatically triggered once the internet is back. So it will start sending the data, even though if app is in background. So we have periodic work manager for that.
Okay. So basically, you can observe it, then the system knows internet connection is gone, and then does it automatically buffer the data now from the temperature, or do you have to do this by yourself?
No, so basically, like when the internet is gone, so we get basically an RPC exception, like from the gRPC. Yeah. So in that, while catching that, we can go ahead and do the operations like what we need. Like, for example, let's say if you are performing some set of operation, syncing some hundreds of list. Let's say on 10th or 11th list, my data went, and then my app broke, or maybe gRPC broke, or maybe the user battery goes off. So obviously 10 or 11 data would have been sent to the server, and that would be anyways removed locally from our app. So REST data, whenever the app comes back into the foreground, so it will be sent back to the server for syncing. Yeah.
Do you know whether the backend has some mechanism, or maybe so wherever the stream goes to so how is it when you lose your connection? Then it knows it. So it's like really like it's not UDP or whatever where it continues to transmit, and you don't know whether you lose your connection. So with gRPC, every site knows when a connection is gone.
Yeah, we know every time connection is gone. Yeah.
Okay. Understood. What else did I find there? And is there a reason why you do you know, as you worked with gRPC with the server and the backend, and you also had this REST API. So what did you use for what? Maybe to ask that way.
So gRPC was in previous project, like most of the companies didn't had backend architecture as gRPC, but my last company has gRPC as the backend architecture. Yeah. I guess we had the differences like gRPC and REST, which I just now said.
Yes, and you said that it's more performant, because when I come back to the context platform, that we're currently basically exchanging data via gRPC, but basically it's also onboard, and to the backend, this is basically our infrastructure. So therefore, that's quite interesting. When we come to this benchmarking, you said benchmark. What exactly did you benchmark here?
So basically benchmarking is like, let's say our Android apps, like on most of the different devices, we find different behavior. Like let's say if our app is being tested by tester, so they find various issues on different devices. So benchmarking is like a library which will give you dependency to test every feature module on every different device. Let's say if it is an Android API 25, 26, 27, 28 level, so there are, that's the benchmark, like, yeah.
Okay. And how familiar are with not Android stuff? So I looked at your CV. You from the very beginning were focusing on Android, I think, because I would be interested a little bit in. You have a lot of data management stuff within the Android framework already.
Yeah.
And how does this compare to non-Android tools? So gRPC is something that is quite common. REST API is something that is quite common. But if you then use this retrofit, for example, or this live data, then it's quite typical for the Android world, is it?
Yeah, I mean it's used for Android only. The example which I said, like Swiggy delivery app, like if you do a network request and if you want to cache the data, so I mean for the data management locally in the app, we use Room database. Yeah, I'm sure like you might have saw the word Room as well somewhere. Yeah,
I've heard of it, yes, but okay, I see.
So basically, let's take a weather example. I have my device in the app, and if I am on one of the locations, I got my current weather, whether it was cloudy, sunny, or something like that. Now let's say if I switch off the app, switch off the internet, and if I come back again to the application, so it should still show me my last fetched location and what was the weather at that point of time. So for that we use Room database. Yeah, so it will be
you store it there
locally stored. Yeah. And whenever the user comes back online, it will again hit back the API via the work manager. It will update the data and remove the stale data because we don't need that. Because if the lat long matches, obviously we know that the data is for same location only. But if the lat long are different, so then there are two entries in the database of the mobile app, right? Because that's how we differentiate based on the lat long.
And you said Room database, but this is something you chose. This is nothing the Android SDK offers, or?
No, it's by Google only, Room database. Yeah.
It's specific. Okay. Because what just why I'm so interested is, but therefore I ask how familiar you are with the Android. We're doing something similar from the methodology basically now without the Android typical stuff, because we were looking a bit more for a generic approach that does not fully depend on Android, as we may use our infrastructure maybe in the Linux world and not necessarily in the Android stack. But first, the mechanism are the same. Second, we still have Android in our cars, where we then have to fit in the things. Just to explain a little bit, so don't fear what I'm leading to. But you have all the technological basis which we need basically to build up our context platform, which we're currently building up. So this is the good thing. I like that. Just to let you know already. Now maybe we go a bit into this context topic a little bit more to get your ideas a bit. So now we just talked about the flaky internet connection thingy. But in best case, we don't have to sync too much with the backend. So we have everything on board. And if you're on board now, and then embedded devices, and I think you're quite familiar with Android apps,
Yeah, I'm quite familiar with all the Android apps on the Play Store, to be honest, because
when you think about performance, therefore I asked a little bit about the benchmarking.
Yeah,
Did
benchmarking is for
this
performance. So basically, there we have like now that you have used the word performance. So basically, what happens is like most of the apps which are low end devices before API level 20 or maybe 21 below 21 Android API 5.0, so they perform differently because a lot of APIs are not supported on the previous versions. So for that we need to have good amount of testing on different devices. So for that we have cold startup, hot startup, and warm startup things, something like that.
Yeah.
So we try to experiment some different things, like if the app was in background on this low end device, how would it perform? If the app was in foreground in a good high end device, so how would it perform? So those are the performance metrics. So for example, the
Good.
metrics here measures are one is frame timing metric, so one is leading timing metric, so one is startup timing metric, like for example how much does your app takes time to start on the first initial screen, and even though after starting, how does it will take time to launch onto a specific segment from, let's say, activity A to B. In Android we call activity. So that's what I have used benchmark for. Yeah.
Good, exactly. That's sorry. Maybe then in the beginning we didn't directly talk. This interesting because what another question. If you think about this data handling you did, so whenever you requested some data from the backend, was this more like one data point, whatever the data point is, for example, restaurants, coordinates, I don't know, per second, or did you deal with data within milliseconds? So for example, temperature every 10 milliseconds, something like this.
No, it was like whenever the user requested. I mean, but the data would come within like hardly one or 1.5 second max. Yeah.
Yes, so I thought so. Therefore, I just asked before I now continue with my question. And if you imagine now in the car, you could imagine that you have a lot of data within seconds. So I don't know, the speed, the location, the temperature, maybe not because it doesn't change so quickly, but any pedal positions, steering wheel positions. Could you imagine from the technologies you used, would they all fit? So could you, for example, if you would use now, I don't know, let's say you have a server in the car that provides data and then you request it via retrofit, wherever you should do it, but maybe you do it. Could you imagine that this, from a performance point of view, would make a fit so that you can get, I don't know, 1,000 different signals a second, or would you have to choose a different technology for that? So you have an UI or whatever, you collect some data in your database, and this is thousands, let's say 1,000, 2,000 per second. And now you need to access the data via one of your keywords you used here. So which one would you think is absolutely not the way to go, and which one could you imagine would easily handle it?
For network request, I guess nowadays there is a new library Ktor as well, so which is supported with Kotlin very much easily. But I will still say like retrofit is good to go, and backend can be obviously if gRPC it sounds good, like it's very much feasible in terms of app performance and the network size request response. It's in KBs, to be honest. Like if you think of millions of users using your BMW's audio infotainment system. Yeah.
Just in the car. So you say it's in the size of kilobytes. I think the data size we have could be bytes and not necessarily kilobytes. I don't know. But then it's at least 100, 200 bytes. So you could already say it's kilobytes. So, but you say retrofit can handle that many requests per second?
Yes. And moreover, like,
I'm not familiar with it.
Yeah. It can handle. Yeah.
Good. And then gRPC you mentioned as well. So thank you very much to your introduction. I had pleasure talking to you. So I will now, I don't know whether you already had the interview with Sophia. Maybe you had it, I don't know. So I will give her the information, and then hopefully soon they will contact you, and then you will know how it goes going on. So I had a good impression, I tell you, but I cannot tell you the overall result. But for me, it's a good thing, and I think it really matches from your CV and what you told me.
Yeah.
Just to let you know. Okay, not the result what the overall evaluation is, but just mine.
Okay, that's
And
nice to
thanks
hear.
for the
Thank you.
yes, and thank you very much. And then maybe see you later.
Yep.
Sometimes. Okay. Bye.
Bye bye. Have a great day.
Yep.
Yep.